Thank you. So first off, I have a question for you. How much data was produced last year, 2023? Any guesses? Feel free to think of numbers. Too much?
Yeah.
We could argue. Well, the correct answer is 120 zettabytes, where 1 zettabyte is 1 trillion gigabytes. They actually had to come up with this new unit to be able to quantify the amount of data that exists in the digital universe. To illustrate further, in these 3 seconds that I paused, 5 megabytes of data were produced per human. Multiply that by the number of days, weeks, years, number of people on Earth, and you get a sense of how huge the amount of data being produced is. Needless to say, the future of business belongs to people who can make sense of these large quantities of data. In light of these statistics, how confident do you feel that you are leveraging data to the best of its abilities? Hi, I'm Grishma Jena, and today I'm here to talk a little bit more about data science. As Mary mentioned, I work as a data scientist with IBM in San Francisco, specifically with the user research insights team. And hopefully by the end of this, I can maybe convince you to come a little bit on the data science side if you're not already sold. What I'm trying to say is that data science is more than just a buzzword. It's a set of methods, a set of heuristics, algorithms that you use to extract insights from data. This is what the data science pipeline looks like. You start off with a question that you want the answers to. Hopefully you have some data sources to look at. You go through the processes of wrangling, cleaning, exploring, creating a model, maybe have to do a bit of pre-processing in there, validating the models, and finally telling a story which ends you with some actionable insights that you can take forward to your stakeholders. Commonly used languages for data science are Python, R, Scala, Julia. You might have also heard of big data frameworks like Spark, Hadoop, and a bunch of other supporting libraries, especially open source ones. But fret not if some of this doesn't make sense, because we are going to go dive deeper into it in the next few slides. You first start off with a question and the data that you have at hand, and you want to formulate a question that your stakeholders are trying to answer. The question could be, who are the next 1,000 customers your product is going to lose and why? Or maybe you want to forecast revenue for the upcoming quarter. You could have structured data, which has some structure, like your CSVs, your databases. You could have unstructured data, like your documents, audios, videos, or you could have something in between, which is your semi-structured data. And just like Legos can be messy and sometimes frustrating, data sources and data handling can be too. After you have the data and the question you want to answer, you go through the processes of wrangling or cleaning the data. Think of it as preparing your data. You want to maybe manipulate some fields, modify the values, standardize them, because maybe people write different things differently, even when it means the same thing. Perhaps you have some duplicate records that you want to get rid of, or maybe you have different scales when you're talking about numerical values. All of those different pre-processing steps that you take forms the data preparation phase of the life cycle. Once you're happy with the way your data looks, you go into the exploration phase. Think of this as getting your feet wet with data. You want to do certain initial investigations using visualizations, maybe looking at the statistical properties of the data. And by the end of this phase, you want to end up with certain hypotheses. Maybe something looks really interesting and unexpected. Maybe something is really obvious, but you still want to prove it rigorously. So that's what this particular phase involves. After that comes the main part, the model building and validation process. When you talk about building a model, the first step you start off with is feature engineering. Similar to how if you were baking, you want to sift the flour, whisk your eggs, maybe you want to melt your butter, that's how you want to deal also with your data set and the attributes present in there. You look at the most important features and try to construct more meaningful ones. For example, you could have timestamp, but timestamp on its own will not give you a lot of information. From the timestamp, you can infer the day, the week, the season, and that then becomes more meaningful to your models. Next up is selecting the model itself, which could be supervised, in which case your data set has labels associated with it. Spam, not spam. Cat, dog. The other end is unsupervised, where there are no labels present, but you're just interested in the structure of the data. Finally, you want to divide your data into training and test sets, very much like how we as humans learn when we study concepts and then give exams or do projects to test the validity of those concepts. You want to make sure that you're monitoring against overfitting. Overfitting is a phenomenon where the model tries to rote learn or just tries to memorize the different results or the outputs associated with the data. And finally, you want to test your model on unseen data, things that it hasn't seen before, to rightly judge it. And some of the metrics that you could use are, one process is called k-fold cross-validation, where your test set and your training set keeps interchanging based on what section of the data you're looking at. And then you have the metrics for accuracy, for precision, for recall, again, depending on your particular use case. And this can be an iterative process. You could have multiple models combined together. All of that is completely reasonable. To go a little more into what the different types of model exist, here's one example of supervised learning called classification. And yes, this is an actual example of a machine learning model that was trained to identify if the given image is that of a dog or a muffin. It is a little tricky, I agree. For example, you could convert that into, is this person at risk of heart failure? And some attributes that you might look at is symptoms, lifestyle, behavior, medical notes. The other type of supervised algorithm is regression, which looks at how much or how many. Maybe you want to predict the revenue. Or perhaps you want to predict future disease outbreaks, in which case you would look at international travel, contamination of air, or water resources. When we talk about unsupervised, clustering comes into the picture, where you're trying to make sense of the structure present in the data. For example, you want to look at different segments of customers present in your product usage. Anomaly detection is another example, where you're trying to detect outliers. And the most classic example of that is credit card fraud detection. Finally, there's another type called reinforcement learning, which has more to do with the realm of robots. You're given an environment, they have an objective, and depending on if they meet that objective or not, you give it a reward or a penalty, and hence the feedback loop continues. So all of that is fine, but things only get done if the data we gather can inform and make a difference. Can you take that to your stakeholders, the people who are in positions of making difference, and make a change over there? That's where data storytelling comes into play. You try to tell a compelling story using your data and your visualizations. And just like classic storytelling, you want to have your characters, your setting, your conflict, and hopefully end with a resolution, just like any good movie or book would be. You also want to look at your narrative, your visuals, and your data, the combination of the three of which helps you affect change. This is what the entire data science pipeline looks like, and we quickly went over each of these different phases. But I'd be remiss if I don't mention, perhaps, what is the elephant in the room. Yes, we're talking about ethics and responsibility. I'm sure we've all come across such headlines, news articles, horror stories in recent months, more often than it was previously the case. And any data that you handle, any application that you create, must be done so ethically and responsibly. I really like this quote from Oveta Sampson, who says, "All data is created by people, and all people create data." Today, we divorce people from their data, and that gives companies the license to forget about the people behind the data. It allows us to divorce ourselves from the responsibility of what that data can do. When we talk about being ethical and being responsible with using data, here are a few things we should keep in mind. Can the tech or the app or the product you're developing be misused? Can it be attacked? In the previous slides, you saw that a lot of our home automation devices can be used for gaslighting or for domestic abuse. Is the data that you're training the models on fair and representative? Or is it just indicative of the majority of the people that form the data that it works on? Are there any biases present, not just within the data, but in the way the algorithm works and the application itself? Do you have a diverse team? Not just diverse in terms of race, in terms of backgrounds, in terms of thought processes, in terms of opinions, in terms of the different walks of life that they come from? Are you seeking explicit consent and protecting the data that you're gaining from your users? And this is even more relevant with all of the AI rules and regulations that we are legally bound to. Does your system continue to stay fair, not just on day 1, but on day 50, 100, 200, 500, throughout the entire life cycle of the application? And if not, is there a way to shut down the system and redress those that were harmed? Yes. You might be wondering, as I notice a lot of you are engineering managers here, perhaps some executives, how this is relevant to engineering. Your teams interact with data of some kind, whether that's internal or external, whether you're a producer of data or consumer of data. And what I'm trying to say is that our traditional agile principles that have worked well for software development, unfortunately, cannot be applied to data science. The whole field of data science is exploratory, experimental, and oftentimes indeterministic. Right before starting the project, or even in the middle of it, no data scientist would be able to tell you how it ends. And despite months of hard work, putting in the hours, giving access to data, analyzing it, you might still end up with inconclusive results, and that's completely valid in data science. At the end of the day, data is the voice of the customer. And data is the language that your customers are using to talk back to you. You're making a difference to their lives, to their workflows, to the tasks that they have to do. You're either improving their experience or making it frustrating for them. And quantitative or qualitative data, no matter the source, is the way they are telling you how they feel about it, what they want out of your products. Now, we did cover the ethical and responsible part of it, but there are a few other best practices I want to leave you with. You need to have access to data that's free from biases, which is what we discussed, but also consider using data contracts. It's exactly what it sounds like, a document where you are defining which team is responsible for generating what type of data, what are the data fields, what is the format like, how frequently the data is updated, who are the owners, who are the stakeholders, so on and so forth. This gives you a source of truth to keep working on data with. Make sure if you're using any vendors, especially ones that store important data for your teams, have APIs. Now, this might seem almost laughable. Isn't it such a basic requirement? Well, unfortunately, I've come across many instances in my career where vendors, even the ones that are in the field of data science, don't have APIs available, which means that the data you put in their system is basically Hotel California. You check in, but you cannot check out, and they hold your data hostage. Not a fun situation to be in. Another really important principle is that of governance. Perhaps you want to have a centralized repository where you are storing all of your data, and you want to make sure that you have thorough and accurate documentation for who's responsible, who's owning this data, and how access can be regulated. This was talking more about the data and infrastructure part of it. But there are also things you can do to encourage a strong and thriving culture when it comes to using data. Consider doing a pre-mortem. You might have heard of postmortems or retrospectives, but a pre-mortem works something like this. Imagine 6 months into the future, your project has been an absolute disaster. Sit down with your team, reflect. What factors might have led to that being a disaster? What were the failure points? Did they not have access to data? Did stakeholder expectation management not work well? Was there a lack of alignment? Was there lack of skills, communication? So many things could go wrong. And doing this pre-mortem will give you an insight into the fears that your team members have. And it can be quite enlightening, to be honest. And once that's in place, work backwards to see how you can mitigate some of those risks, or maybe even prevent that from happening in the first place. Like I said, data science itself is extremely experimental in nature, which means you're bound to run into problems and failures and challenges of all kinds. Encourage your team to fail. After all, failures are the stepping stones to success, right? And once they fail, they'll still learn something. And perhaps the next time around, they'll be more successful. Or maybe they'll share their learnings with their team members and help them from making the same mistakes. These conversations about data science, machine learning, AI, being responsible, being ethical, are more pertinent than ever. Because, let's face it, whether you like it or not, all of these aspects are coming into your life one way or the other. Whether you are creating these very systems or being the user, whether it's being intentional or maybe it's hidden behind the covers and you don't even know about these algorithms in the first place that are taking these life-altering decisions for you. Remember, data might be the new oil, but it's your leadership and your support that will refine it into the fuel for innovation. Thank you.